Magandang araw, ako si Sir Richard and welcome to a video of Basic Calculus. We are using the Calculus of a Single Variable 10th edition by Larson and Edwards. So the topic is the derivative and the tangent line problem. So objectives: find the slope of the tangent line to a curve at a point and use the limit definition to find the derivative of a function. So tangent line problem. Calculus grew out of four major problems that European mathematicians were working on during the 7th century. First, the tangent line problem. We also have the velocity and acceleration, minimum and maximum, as well as the area problem. Okay, so differential calculus is concerned with finding out how fast a function's value is changing as x changes. And that is the rate of change, what we call the rate of change. Rate of change. Now, with algebra, ang rate of change also corresponds with the slope of a line. So, if you can remember, slope of a line, which uses the symbol m, is rise over run and run. In this setup, ang rise natin is 1 and ang run natin is 3. So, 1 over 3 ang slope ng line nito. So, ito yung example ng mga linear function na pwedeng nagre-represent ng real-life scenario. Kunwari, in 1 year, nadagdagan ng 1 million yung population, in 3 years, 1, 2, 3. Nadagdagan ng 1 million yung population ng certain area. O kunwari, merong magsasaka na meron siyang kalabaw, after 3 years, nadagdagan ng isang kalabaw yung alaga niya. So, yun yung example ng sa rate of change. Now, okay lang ang slope, madali lang ang slope kapag linear function. Pero what if curve yung line? So, what if tataas yung line? Hindi na natin pwedeng gamitin tong slope na to kasi para lang siya sa linear function. Now, paano naman natin kukunin yung slope ng curve at line? So, ang slope ng curve, slope is a line that is tangent to a curve at a point. So, for a circle, madali lang siya. The tangent line at a point P is the line that is perpendicular to the radial line at point P. So, ito yung radial line, yung radius. Perpendicular siya. Yung tangent is, nag-touch lang siya ng once dun sa curve ng circle. Yan. So, a line is tangent to a curve at a point P when it touches but does not cross the curve at point P. So, ito, okay to. With that definition. Kaso, ito, nag-cross siya doon sa ibang curve. So, how are we going to get the tangent line at a point P kung meron tayong curve? So, actually, ang isang way is to use we can approximate the slope by using the secant line. Secant line is from the Latin that means to cut. So, I have here one point, C, f of C, and may delta x. So, from this point up to this point is delta x. Yan. So, may sasama natin yung delta x doon sa part na yun, ng C and f of C. Just to recall, y is equals to f of x. Yan. So, ginamit niya lang dito, isabi na ginamit niya dito is yung f of c. And yung x is c. Okay, so yan yung dalawang points na meron tayo. So, c, f of c, yung first point, and yun yung point of tangency na tina-target natin. And yung second point na gagamitin natin is the c plus delta x and f of c plus delta x. Now, going back, ang formula ng slope is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So, y sub 2 natin is ito. F of c plus delta x minus y sub 1 f of c. Ayan. Then, x sub 2 is c plus delta x minus c. So, c plus delta x minus c. So, x sub 2 minus x sub 1. So, kung i-simplify natin, c minus c, cancel out. So, delta x yung nasa ilalim. So, ang slope ng second line is f of c plus delta x minus f of c all over delta x. Yan. So, with this one, we can approximate the tangent line ng point P pag ginamit natin itong slope ng second line. So, mas malapit yung data, mas malapit yung from point 1 and point 2, so this is point 1, P, and assuming this is Q, so mas malapit yung approximation or mas accurate yung approximation ng slope of the tangent line. So, ganito nga yung itsura niya. Yan. Siyempre, hindi tayo pwedeng ilagay yung point Q doon sa point P kasi dividing by 0 is undefined. So, mas malapit, mas accurate yung approximation natin nung tangent line. Yan. Okay? Okay, so definition of tangent line with slope m. So, delta y over delta x. Delta is change. Triangle is called delta, and that is actually change. Change in y over change in x. So, delta y over delta x is the limit of f of c plus delta x minus f of c all over delta x as delta x approaches 0. So, kanina nga kung mapapansin nyo, habang lumalapit yung q, yun yung idea ng delta x approaches 0 hanggang sa halos dikit na, infinitely close. So, the slope of the tangent line to the graph of f at the point c, f of c, is called slope of the graph of f at x is equal to c. Okay, so example number 2. Tangent lines to the graph of a nonlinear function. So, this time hindi na siya linear, parabola na siya. So, find the slopes of the tangent line to the graph of f of x is equals to x squared plus 1. At the point 0, 1, ito, si 0, 1, at negative 1, 2. So, okay, so using the idea of using the slope ng second line, we will apply the setup. So, limit delta x approaches 0, the limit of f of c plus delta x minus f of c all over delta x, which is equals to, so gagamitin natin, pag x, dito, ang gagamitin natin sa lahat ng x is c plus delta x. So, the limit of delta x as delta x approaches 0. So, f of x squared plus 1, kaya gagamitin natin dito is c plus delta x. So, c plus delta x squared plus 1 minus f of c or f of x is x squared plus 1. So, c squared plus 1 all over delta x. Okay, so dito, limit of the function as delta x approaches 0 ay, expand na nito, c plus delta x squared. So, we have c squared plus 2c delta x plus delta x squared plus 1 minus c squared plus 1. So, minus c squared minus 1. Dapat minus to. Minus 1. Ayusin ko lang para hindi confusing. So, minus 1. Delta x. Now, kung isi-simplify ko to, mawawala si c squared. Mawawala din si positive and negative 1. Ayan. So, matitira is 2c delta x plus delta x squared. Okay, so the limit of the function as delta x approaches 0 is 2c delta x plus delta x squared over delta x. So, simplify, delta x approaches 0. Kung pag-iwalayan natin itong function na to, may kanya-kanyang delta x. So, matitira is 2c plus delta x. Kung makakancel to, at ito, isa. So, 2c plus delta x. Okay, so ang point dito is what will be the value as what will be the limit as delta x approaches 0. So kung ito is magiging 0, ang limit natin is equals to 2c. Okay, so what is the slope of the line at a tangent line at negative 1, 2? So, negative 1. So, una dito, gagamitin natin. So, 2c. At negative 1, 2. So, m is equals to 2c. So, that is equals to 2 times negative 1 or negative 2. So, at 0, 1. So, m is equals to 2 times 0. So, m is equals to 0. Ayan. So, the slope of f at any point, f of c, is m is equals to 2c, which is ito nga. So, kapag in-apply natin, based on sa points na given, at negative 1, 2, ang slope natin is negative 2. At tangent line at 0, 1, ang slope natin is 0. Okay, so there are instances na meron tayong vertical tangent lines. Hindi applicable yung derivative kapag may vertical tangent line. Yan, katulad nito. So, the derivative of a function, this time, didiretso na tayo sa idea nung sa derivative. The limit used to define the slope of a tangent line is also used to define one of the two fundamental operations of calculus. So, yun nga is, yung isa doon is differentiation. So, the derivative of f at x is equals to f prime x. So, f of x, kapag ginawa natin yung derivative, that will become f prime x is equals to the limit of the function as delta x approaches 0. Ito kung matatandaan nyo, that is the slope of the second line. Provided the limit exists for all x for which this limit exists, f prime is a function of x. Pag nakuha na si derivative, ng f of x, magiging f prime x na siya. Okay, moving forward, f prime x ang basa dito. Then, the derivative also has different notations, f prime x, dy dx, or the derivative of y with respect to x, or simply dy dx, or y prime. Then, d over dx of f of x, and dx or y, dx of y. So, yan yung mga notion kung paano natin pwedeng isulat si derivative. Okay, so example number 3. Finding derivative by the limit process. To find the derivative of f of x is equals to x cubed plus 2x. Use the definition of the derivative as shown. So, x